Now we have another guest, Dr. Anurag Kaur sir, and I request to Dr. Ravi. Dr. Ravi, please give planter and welcome Dr. Anurag Kaur sir. Please. And thanks Anurag sir.
थोड़ा सेंटर में
Now in this welcome sequence, we have another guest, Dr. Sanjeev Kumar sir from RKPG College Shamli. Now I request Professor R.S. Yadav sir, please welcome him with the planter. Now we have another rock star, Dr. Y. K. Gautam sir, and I request Dr. Rakesh Rana sir, please welcome him. And a round of applause. Now the session will continue with talk of Professor Anush Kumar sir. Please, Anush sir. Now, dice is yours and mine is yours.
Distinguished speakers, faculty of the institute, and dear students. दिख रहा है रिस्टार्ट करो ना हो तो अंदर सर के ऊपर ये स्लाइड सर की है उसके नाम देखो ना सर वो एंटर होगा कहाँ गया तो भगवान ओके सर ओके
topic as a director. Today I will talk on the engineering of donor structure architecture for next generation knowledge of engineers. EFT की बात करेंगे and थोड़ा सा taking the perspective of the EFT and then I will take one example जो हमारा student हमारे काम कर रहे हैं. वैसे I will take one call just run the brain that how EFT can be utilized, what type of work we are doing in our work. Next slide. ये हम लोग थोड़ा सा स्टार्ट करते हैं आपकी दृष्टि है इनोवेट बट बिफोर वी स्टार्ट दी ग्रेजुएशन अपनी दृष्टि के बारे में आप लोगों को वैसे मैक्सिमम चीज़ें पता है और फिर भी थोड़ा सा डेफिनेटली इफ यू आर नॉट अवेयर यू विल गेट something about your industry. We are 8++ net affiliate. NRF में देखो आप तो 41 है हमारा स्टेट कैटेगरी में एंड एसटी कैटेगरी में दिया 151 250 200 वाला जो ब्रैकेट है उसमें है. We are also placed in US rankings and similarly very prestigious Times जो Times University ranking है वर्ल्ड टाइम्स यूनिवर्सिटी रैंकिंग. We are in the bracket of 1201 to 1500. Basically, ये इंटरनेट I have not shown all, but ये बहुत ही prominent है जो rankings आपकी यूनिवर्सिटी के पास हैं. So that gives you the idea that what university is doing. On right side, you can see our 59% publications having impact factor more than 5. Highest publication impact factor is 42.5, H index 51, and it's for last 5 years only. Average citation is more than 12, and if you talk in terms of quartiles, we have 37.3% of publications in the Q1 type, जो top rank journals होते हैं, उसमें quartile 1 में university के publications. So with this, now I am coming on the topic next one. This is my group, what I am working. Usually I am working on the two part. One, nanoparticle synthesis, characterization and applications, mainly supercapacitors, both materials, electrolytes, electrodes. On the other hand, I am working in reactive applications. One part, I am talking of understanding structure of the relationship, spectroscopic analysis, non-linear optical and biological activities. Non-linear part we will discuss today, and also I am working using EFT for sensing applications. So this is the area in which my group is working. Next one. So in this discussion, first we will spend some time briefing some information. Most of the colleagues, our colleagues who are working at EFT, they are aware, but for the students, I would like to give some brief idea how materials modeling helps in understanding and evaluation of the properties. Now, theoretical calculations, theoretical work is important when you are talking the work for the materials. Advantage you can have because you can have theoretical calculations. They can offer quick and inexpensive way of predicting the properties of material. This is a very important thing. Before you doing experiment, you are not spending anything like you are not playing with the chemicals, and many times you find when you are using chemicals, some chemicals are hazardous. So before you actually do the experiment, you calculate and you know whether a particular output, what you expect experimentally, can be obtained or not. So it's kind of a validation you can have. Next one, you can talk, you can understand also, can interpret at the atomic level. Many properties you can correlate in that way. We can have predictive values, structural, spectroscopic, electronic, chemical, optical, biological, many properties you can predict before they are actually investigated experimentally. What it can result? These predictions can result in new material. You can design a new material. In material engineering, you can just say by for the desired properties. So before you go, you don't have to do large number of experiments, sometimes attempt trial, and then rejecting the output if it is not worthwhile. So you are doing it, doing the calculations, output you are checking, modulations you are doing, and you are getting the material which satisfies your requirement. So that is the basic advantage of the computational chemistry, or you can just say the theoretical calculations for the materials. You just say it's one tool which gains inside the atomic and molecular level that we have already mentioned. Next one. How it is done? Quite simple. Materials essentially consist of electrons, nuclear charges, and so what you have to do, you have to model the material accordingly. Basically, the atoms consisting of nucleus, electrons, interaction, when we are talking of bonds, interaction among the electrons and the nucleuses of different atoms. So, if you know how these atoms interact, if you can understand at the atomic level, electronic level, the interaction of these, then, and even if you know the pathways of reactions, you can have the basic information about the material, you can predict many properties. Next one. So, I started this, the quantum chemical methods initially, and basically when you talk, you use the two different models, the classical models, and also the quantum models. Classical models will come, they are not so expensive calculation wise, but accuracy is always challenged. So that we discuss the next slide. Yes, here you can have different quantum mechanics application, quantum mechanical methods, the molecular mechanics, classical one, not talking of molecular mechanics and present in quite detail, because quantum mechanical methods are relatively accurate, but they are time consuming. But now we have facilities, we are having fast computing, computers, and also processors we are getting which are very fast, and therefore we can go even for the relatively higher systems, bigger systems, we can go for quantum mechanical calculations. So quantum mechanical calculations are becoming popular day by day. I will talk on that. If you talk of the quantum mechanical part types, it has ab initio methods, starting from the scratch. You simply solve the Schrodinger equation and then find the wave function and corresponding energy and other things. Other we have another method, semi-empirical method, in which what we do, we don't solve all integrals. For some integrals, we add parametric values. Known values from the experiment can be added. So what is done, what you are doing, you are reducing the computational cost drastically. Third one is very important. I will emphasize on this particular part. It's very popular, and it is density functional theory. Next one. Next one. Yes. यस, ये थोड़ा सा एक तरह से कंपैरिजन दिखा रखा है computational cost versus accuracy. On the x-axis you can just see how large the molecule is, depend you just say number of atoms, and on the y-axis you talk of the accuracy. So if you see quantum mechanical methods, they are applicable generally because it requires a lot of computational cost, consumes a lot of time, so they are generally applicable for somewhere around having atoms of the order of 100 atoms. And if you are dealing with such kind of materials and atomic systems, it is better to go for the quantum mechanical methods. But if you are talking of large molecules like proteins, DNA, RNA, then the molecular mechanics referred. So both have importance. I am working specifically for the quantum mechanical part. Next one. Next one. ये थोड़ा सा ब्रीफ पे रखा है जो ऑलरेडी आई मेंशन अविनिशो मेथड्स में आप सिंपल यूज करते हो हैमिल्टोनियन वाला कांसेप्ट जनरेशन डेंसिटी फंक्शनल थ्योरी आई एम कमिंग ऑन दैट डेंसिटी फंक्शनल थ्योरी यूजेस रिलेटिवली डिफरेंट कांसेप्ट एडवांटेज यहाँ क्या है कि यहाँ पर वी आर चेंजिंग द वेरिएबल्स नंबर ऑफ वेरिएबल्स रादर देन यूजिंग xyz for every electron we are dealing with the density. So it average of density of electrons, and that is how you are reducing the coordinates drastically. Basically you are talking of in terms of the 3 coordinates only. So that is you can reduce the computational cost to a large extent without compromising the results. Next one. Next one. ये थोड़ा सा बैकग्राउंड है डेंसिटी फंक्शनल थ्योरी की. फंक्शनल थ्योरी वाज इंट्रोड्यूस्ड इन 2 seminal papers in 60s by Cohen पर Cohen 1964 and Cohen-Sem 1965. ये जो citation निकलता है थोड़ा सा कम यहाँ पर दिया हुआ है, continuously increasing. But if you look downside, I have mentioned something. If you look in 1986 with the word density functional theory, you search the title or abstract yields less than 50 entries only. 1986 and in 1996 में अगर देखें और 2006 में अगर देखें तो respectively 1100 and 5600 entries, and at present if you look 23,50,000 entries and counting. ये 2-3 महीने पहले कुछ मैंने गूगल से सर्च किया था, ये डेटा नंबर आ रहा था, ये उस टाइम का है 3-4 महीने, और मे भी 3-4 महीने में और कुछ 1000 तो एटलीस्ट बढ़ गया होगा लाइक थिंग. So this is how from this data you can appreciate the importance of the density functional theory. And considering that importance, these people Walter Cohen and Johann Epicel, they shared the Nobel Prize in 1998. Next one. Basic concept I have already mentioned, but here you can easily understand that if you talk of the ab initio methods, it deals as the many radical, you have large number of electrons. So for all electrons, you have to write the direction, and for every coordinate of every electron, you have to write certain equation part. So a lot of variables are there, and solving is difficult in that way. So a lot of transformation you have to involve, and definitely change. But on the other hand, if you are talking of DFT, you are dealing with the density, electron density. You have nucleus, and around these nucleuses are placed in the electron density. So things are relatively simpler. But how it is done, that we talk. In the density functional theory, we talk, as the name suggests, density functional theory. So what is functional? Basically, functional is a function of function. So we are talking, we talk of energy, ground state energy, in terms of the functional of the density. And density itself is a function of xyz. So it's a function of function, and that is the functional, and that is why this is known as density functional. Next one. Now I am coming, as I mentioned earlier, in this particular talk, I am concentrating only very small part of my research, and that is on the non-linear optical materials. You just see they are very important, applicable based on their different properties like resistance to optical damage, resistance to carbon, non-linearity, biophysics, optical transparency, and right side you just see the applications where you can apply or use these non-linear optical materials. Next one. Here I have mentioned some concepts. Basically, polarization is presented like this, different orders, and you have linear susceptibility, second order non-linear susceptibility, third order non-linear susceptibility. So various susceptibility components you have to calculate. And here you can just see alpha, beta, which is called polarizability, first hyperpolarizability, second hyperpolarizability. What happens and how these alpha, beta,
इससे स्टैंड मंगवा लो मुझे तो लगा प्राइस डिस्काउंट से होगा
are related with the experimental laws.
मुझे नहीं पता था ना
Here and
कैसे चलेगा
right
उस
side,
लड़के से मंगवा दो
right
क्या
side,
नाम है उसका?
get various parameters like alpha, beta, gamma, how they are connected with
चार्जर भी मंगवा देना सर
applications.
चार्जर भी सोफे पे रखा है
Application you are looking for, you have to concentrate on that particular aspect of the material. So when you are doing theoretical calculations, you are predicting some material or you are doing some a kind of predictive thing, you are trying to find some new material, depending upon the application, in which area you want to predict what type of material you are looking for, you have to concentrate the values of that particular related alpha, beta or gamma. Next one.
पावर पे का पार कार्ड वही
Here
टेबल
I
पर
take one example. My student
सोफे पे या टेबल पे नहीं
has
नहीं नहीं सर रूम में है
to be published. We are writing it. Structure.
स्टैंड तो मंगवा ही लो पावर बैकअप में तो अभी घंटा चल जाएगा
So what we have to do this one and what we have done, we have taken the base
दे तो दी अभी तो पकड़ाई है सर
2 methoxy and diphenylbenzamide, 2 mn TPB group. We have taken a group and what we have done, we have changed the functional group attached to this particular base. So you can just see 15 functional groups we have tried. They are written here and we have calculated various properties, specifically the non-linear optical behavior, and depending upon the property what we have found that for a particular structure the best value we have obtained, and for that particular molecule only then we have done a lot of calculations and a lot of properties understanding at the atomic level. Next one. Next one. Same thing. That various analysis techniques have been used. So I will some of them I will show here. Next one. Here is the base. So R is substituted and 15 substitutions we have done and accordingly we have calculated properties. Next one. First step is back. We have to optimize the structure, minimum stable structure we have to find, and then basically this minimization, the optimization is just to validate because use of different data sets and various methods results in different values. So first is to optimize all these things. We use generally available experimental results for this particular one as far as the available. In this case, we have for one structure experimental values are available and for every 40 we have the predictive values. Next one. So how incremental optimization is done? Only one molecule I am going as the representative which has the maximum non-linear. Next one. The electronic level in terms of the electronic structure, how many calculations are done, what is the difference between or we can say the band gap, because these band gaps are responsible for the intra-electron transfer, charge depolarization among the molecule, and nonlinear behavior actually responsible or associated with this charge depolarization. So various property analysis or analysis which basically provide information at the atomic level on the charge transfer. These
Things are done and analyzed. Next one. Global
descriptors we have calculated for specific.
So the result. Next one. The another representation graphically is the molecular
Electrostatic potential, which gives you how the molecule is polarized, what is the charge distribution at different points of the molecule. It's not only used in its molecular part, but it has various applications. Specifically, we saw molecule as a biomolecule, as a addition. Then this understanding also becomes very important, because this decides in various locations where the viruses or other things can interact, or you can say your addition can interact with the viruses, bacteria, and how they can destroy it.
molecular changes. Next one. So this is how it's represented. I'm not going into details. By click, if you just see the red color, basically the charge, electron charge energy, higher electron charge energy. So the negative potential, and the blue basically represent the positive potential at the different part of the molecule. Next one. Natural bond orbital analysis is basically represent how the what is the intramolecular charge interaction. So I'm not going into detail of these values. Basically, it gives intramolecular charge transfer, how the molecule, the charge is transferred from one state to the other state. Next, and one part of the molecule to the other part. Now the non-covalent interaction of the non-covalent interaction also provides the possibility that how molecule will react when it is exposed to the active field and rapidly connected with the non-linear field. Next one. Next one. Here are the properties. Some part we have already discussed. Here the various parameters which are calculated by the software, and then the various values are calculated. Next one. Here is the data which for different all 15 we have different values, and if you compare this one, I think visible, we are having very good, almost 27 times the beta of the standard urea, which is considered as the reference. So this particular molecule is very useful, or maybe if it is synthesized, it can have better nonlinear optical applications. So this is kind of a predictive thing. We have predicted that this particular molecule can be utilized having very good nonlinear optical applications. Next one. These are the values. Next one. So finally, what we conclude in the present part, series of 15 donor acceptor substituted derivatives of this particular 2ml DBV were successfully designed and theoretically predicted using DFT approach. Methoxy group replaced with the various donor acceptor substituents and analyzed various property analysis methods. Overall, the design derivative exhibit significantly enhanced analytical properties. Among these, we having SO2F substituted molecule exhibited the highest first order metabolizability, that is 5.38416 in the 30 years, which is 27 times greater than the urea, and this higher value suggests that this molecule is useful and potential candidate for nonlinear optical applications. Next. Thank you. Next one. Next. Thank you.
Thank you very much for the nice talk. If any question, one or two from the audience. Okay, thank you. Thank you again. Ladies and gentlemen, we have last Professor Mario Works. I request you, please. This seminar contains an technology and truly interdisciplinary research. बहुत ही अच्छा लगा मुझे यहाँ पर आने को और बहुत अच्छे रिसर्च वर्क इसमें प्रेजेंट हुए and really impressed by the work that this organizing committee has done and also the people in this area have done so much of very good research work. What I propose to do now, in fact, I wanted to do 3 aspects, but I will only cover one of them. And there have been very few papers on space. So let me say something about space to start with. Space is a very wide interdisciplinary system, and it encompasses astronomy, astrophysics, planetary science, atmospheric science, atmospheric physics, and newly emerging fields like astrobiology and space medicine. All these, in fact, come to space science. And in fact, there are some very simple questions that come to very common mind. And those questions I will only give you a method by which you can learn in a very simple way. And this next slide, please. Next slide. Next slide. The simple way is by graphic novels. And these graphic novels were first designed, developed in Japan in Japanese, because Japan has a tradition of using this graphic novels for education for many, many years. And then some scientists of Japan who are working with NASA in US, they got sort of impressed on that. And then NASA scientists and Japanese scientists put together, translated those books into English, graphic novels. And once they were done in English, then they sent to many people around the world and suggested to them that if they wish to translate these into their own languages, we will give them this blank cartoon and fill the material in your own language. So I offered to do that in Hindi, so I will show you that. Next one. So this is the program, a scientific committee on space, solar terrestrial environment program. It's a universal committee, and this committee owns these graphic programs. So can you click on the first slide? The first slide over here. First slide. Look. Go to the next slide. The first slide is space science coming books. Click on that. Inside the right? Click on that. Click that side to you.
बस यहाँ पे है ही नहीं सर आगे सर क्या बात कर
So ये basic question सभी स्पेस साइंस के क्वेश्चन है. What is vulnerability? What is aurora? What is vulnerability? And what is sun climate relationship? What is global warming? What is ocean ozone hole? And what is upper atmosphere? What is solar wind? And what are cosmic rays? In these short rapid novels from the book, all these subjects are very simply described by there are three characters in this. One, a little girl who is very curious to learn about science, and her dog that also plays with her. And they go to their questions to the scientist, and the scientist answers these in a very tutorial form, very few words. So all those books are available in this slide. If you have internet on your computer, and I request the organizers to give these slides to any student or any department, anyone who wants to have them and use them. So, here I showed is how these slides open. So one of the group was what is upper atmosphere. So that is this one. And in fact, I know is the purpose to design these problems, and this is the team of the scientists who created these images. That's right. So this is the way they explain that the upper atmosphere is divided into these four parts, like troposphere, stratosphere, mesosphere, thermosphere, and what are their purposes and what action really happens in these. These are all described in this, and it is true for all the 8 or 9 topics that we are listed there. Very beautiful. In fact, by translating this from English to Hindi, I myself learned many things which I had not learned after doing 40 years of research work in physical research laboratory. So maybe at this point I close, and I again request the organizers to distribute these slides to as many people as possible, especially these 3 slides, so that they can know. In fact, all my slides can be shared with anyone. There is no maybe I will talk with this, and now I request the colleagues, the days and please make sure to this. And that also is that what we cover the kind of what we do. I have prepared to the research. Mr. Gary, please.
Thank you very much. मैं मनोज कुमारी से रजित और इन्वेस्टर कर सकते हैं। अब हम आखिरी मुकाम पर हैं। और मैं सभी अपने जो गेस्ट ऑफ ऑनर्स हैं उनसे आग्रह करता हूँ जो हमारे गेस्ट ऑफ ऑनर हैं अबोली रमेन विद्यास कराने का कष्ट है। जी सर।
जी सर। सर आइए सर।
Sorry. थैंक हमारे बीच में दो अतिथि और है जिनका हम सम्मान नहीं कर पाए। डॉक्टर गौतम कृपया नमस्कार आए। डॉक्टर गौतम जी,
Gautam sir, please come on that.
और मैं निवेदन करता हूँ कि हमारे सीनियर नगर निगम डॉक्टर नाडी को बैठे हुए हैं, वो उनको सम्मानित करें। मैं डॉक्टर दीप्ति रानी से आग्रह करता हूँ कि वे हमारे अतिथि डॉक्टर शिवानी अग्रवाल जी है। थैंक यू वेरी मच। देवियों सज्जनों, हमारा 2 दिन का जो टैक्स शुरू रहा है और आप लोगों ने बड़े धीरे पूर्वक, मैं समझता हूँ कि बहुत सारी साइंस को सीखने का प्रयास किया होगा। हमारी ऑर्गेनाइजेशन, हमारा एडमिनिस्ट्रेटिव ऑफिस सतत प्रयास करता है कि आपको किसी तरह की असुविधा न हो। टाइम भी बहुत हो चुका है। मैं डर से में तो शुरू करता हूँ प्रोडक्टिविटी ऑफ द कॉन्फ्रेंस। जहां तक इन्वाइटेड लोग की बात है, हमारी प्रोडक्टिविटी 115% रही है। हमारे पास 16 इन्वाइटेड लोग थे और 18 इन्वाइटेड लोग यहाँ पर हमें इट इज अबाउट 115%। ओरल प्रेजेंटेशन हमारा थोड़ा हुआ रहा है, इट इज अबाउट 65% प्रोडक्टिविटी रही है। थर्ड पोस्ट प्रेजेंटेशन हमारा 135% रहा है, क्योंकि लास्ट मोमेंट तक भी हमारे पास कई रजिस्ट्रेशन और कई जो पहले इंडिकेट नहीं कर पाए थे उन्होंने इंडिकेट किया है और वे आए। इट इज अबाउट 135%। प्राचार्य जी के आज्ञा से मैं आपको अवगत करा था हमारी 2 पैरेलल टीम थी जो मॉनिटरिंग कर रही थी, इवेल्युएट कर रही थी। क्योंकि मैंने पहले कहा था कि बेस्ट पोस्टर प्रेजेंटेशन अवार्ड्स डिफरेंट स्ट्रीम में दी जाएगी। बेस्ट ओरल प्रेजेंटेशन अवार्ड भी दिया जाएगा, बेस्ट सिंथेसिस अवार्ड भी हम देंगे, बेस्ट थीसिस अवार्ड भी। और आई एम वेरी हैप्पी से कि 2 टीमों ने जो डिसीजन मेक किया है वो ही डिसीजन आप, तो हमें कोई चिंता नहीं हुई इस बात के लिए। सबसे पहले मेघनाथ साहा बेस्ट पोस्टर अवार्ड, एक बहुत सुंदर पेपर था रिया एकर के नाम का। रिया एकर, हाँ रिया टाइटल वाज AGRM and XCRM मैं चाहता हूँ कि आप पूरी टीम यहाँ पर आए। मैं प्राचार्य जी से और एक शब्द से निवेदन करता हूँ मेरे बच्चों को मेघनाथ साहब नेक्स्ट पोस्टर अवार्ड देकर उनका अवसर तय करें, क्योंकि ये अवार्ड पोस्टर को दिया जा रहा है एनी इंडिविजुअल सेंटर। थैंक यू वेरी मच।
टीचर्स का रोल बहुत रहा है।
Second, Dean Sahni Best Poster Award to Miss RTC. मैं निवेदन करता हूँ प्रोफेसर अमित कुमार जी से और डॉक्टर प्रकाश चौधरी जी से आगे आए और ये सम्मान देकर आप ऑनर करें। Thank you very much. Next was Har Govind Borana, Best Presentation, Oral Presentation Award
जी सर नमस्कार।
goes to Miss Achal from Kalindi. I request our principal, Professor Sudhir Kumar. Best Poster Presentation in Ramanujan Best Poster Presentation Award goes to Mr. Mohit Kumar. Mr. Mohit Kumar is here. Okay. Beautiful. SN Bose Oral Presentation Award Miss Harshita Kadam. Harshita? Sorry, Hamsika. Hamsika here? She from Dartmouth. Okay, anyway. मैंने पहले आपको अवगत करा था कि ये कॉन्फ्रेंस डेडिकेटेड टू नेक्स्ट जनरेशन, ताकि हम इस समाज में बच्चों के समाज को कनेक्टेड कर सके साइंस को पॉपुलराइज करने के लिए। इसलिए हमने